This is Dr. Frederick. Let's find a Z calculator. Here's one of my favorites. So David Martindale's Z calculator. And let's just take a look at it here. Now what we want to do is notice that these are z-scores. Now z has a mean of 0 and a standard deviation of 1. Scores to the left are below the mean and have a negative z-score. Scores to the right are above the mean and have a positive z-score. And so mean 0, standard deviation 1. And now let's just look at between -1 and 1. The shaded area is 68% of the area under the normal curve. So if 68% of the normal curve is between -1 and 1, what we really say is there's a 68% chance that any score randomly chosen here will be very close to the mean, within 1 standard deviation. If we change that to a -2 and 2, then it's closer to what, 95%, something like that, 95.4%. So if we randomly select a value under a normal distribution, 95% of the time it'll be within 2 standard deviations of the mean. Now we can take any point here and find the area under it, because this was calculated out a long time ago. So if we want to find the area between 1 and 2, we can do that. Here's the area, and that's 13.5%, 13.6%. And that's actually the same amount between -1 and -2, because the normal curve is symmetrical. Okay, so we can play this all day long. We can find the area between 2 points. And so, very commonly we know, I know all of these areas. This is 13.6%. This is 13.6. What is this? 34%, 34.13 if I recall. So let's find the distance between, 34.13. So -1 and 0 is 34%. These are values that we just know. So, from the mean to 1 standard deviation above the mean is 34.13%. From the mean to -1 standard deviation below the mean, or 1 standard deviation below the mean, is 34.13%. And then what? We can go 0 to -2. That's going to be what, like 47%, 47.7%. From -2 to 2, it's going to be 95%. Almost all of the curve is between 3 and -3, 99.7%. Very, very unusual to find a z-score greater than 3 or less than -3. This is, this line goes on infinitely, theoretically, but of course, it's hard to get away from the mean. It's very unlikely. It's hard to get away from the mean means the same thing as it's unlikely to be distant from the mean. Very low probability of being out here, very high probability of being right here. In the normal distribution, area equals probability. So I hope that's helpful to you to understand how to do this problem.